Hey there, welcome back to the channel. Today, let's talk about building user interfaces for embedded projects. You can see what I've got here is a simple user interface. This is a SPI display, so it's a serial interface. We've got several labels here, some symbols, the percents and degree symbols. We've got some icons up here. We've got some images, a little bit washed out, but you can see it's a circle with another circle inside of it. We've got backgrounds that are changing. We've got labels that are changing. Let's go take a look at one way that you could build something like this using a .NET application. First, let me define the types of use cases I'm talking about. If you've got a full display, something, with HDMI or DVI or that type of an output, that is not what I'm talking about here. For something like that, you typically will use a UI framework running on a full operating system, such as Linux or Windows. You've got a whole bunch of options. My preference there would probably be to use Avalonia. You could use Maui. You could use potentially WinForms, GDK. There are a lot of options. That is not what I want to talk about here. What I want to talk about are simple serial displays, either SPI, I2C, or in some cases, even potentially UART. I've got a bunch of examples here. We've got standard TFT type displays. These use SPI to talk to them. This is an e-ink display. This is a small OLED that uses I2C. We've got something here that this is just a pixel display. It's a monocolor. This actually is monocolor as well, but these come in different colors. You can get them in red, green, blue, white, a few different things like that. But each one of these LEDs basically is a pixel. Then we've got a character display here. This is a 4-line characters display, so it doesn't have the ability to do graphics, only characters. These types of devices are what I'm talking about. When we want to use an application, a typical embedded app, oftentimes we'll have a fixed display with a fixed resolution that we want to do a design for. If you've been watching this channel for any length of time, you're probably familiar with this. This is the Tilt project. We've got a microcontroller. This is a Meadow F7 Feather. I've got an accelerometer, a INA219 for monitoring power, and then I have this display. This is, again, an I2C monocolor display. So if I have an application that wants to use something like this, and I've got a couple of different ways for viewing. This one has this little circle that moves around. So I have that. I also have, if you get a command, it will show an icon in the center of this screen. And then I can push this button and change the display. So over here, I've got a few different labels and a bar chart. So the question you ask yourself when you're designing something like this is, how am I going to draw the graphics and text on this from an application? These take a single command, and in fact, every one of those displays that I showed typically has different types of commands for updating them. Sometimes they can do updates of regions. Sometimes you have to write the entire frame buffer to the display. There are a lot of complexities in that. The first thing that we did at Wilderness Labs is we created something called micrographics. That abstracts all of these displays to the same interface. It's an iPixel display. So anything that displays in pixels, that has controllable pixels for the display, can be driven with an iPixel display interface. So they all look the same from a code perspective. That gives us the advantage of, if I'm driving something like this to begin with, and then I want to move to a larger display, I really don't have to change much in code. I might have to change resolution, so height and width, for what I'm doing, but that's all you will have to change. So that greatly simplifies things. Let me pull up the micrographics example and show you what that looks like. You can see here that the pixel display just has some very primitive properties and methods for the display. We expose things like the color mode, the width and height of the display, things like its color, and then it has clear, show, fill an area, draw a pixel in a certain color, and it exposes the pixel buffer here. Some very, very low-level raw stuff that you can indeed use to draw. Micrographics builds on top of that. You can see that it takes in a pixel display. This is where that ability to move between different physical displays makes it easier if they all implement the iPixel display. Then this gives us some things like drawing a rectangle, inverting one, drawing a pixel, drawing text, drawing a triangle, rectangles, some things like that. So still a lot of primitives, but at least some things that are built upon the pixel display. So if I want to draw a rectangle, I don't have to specifically figure out the XY position of all the pixels. It will do that for us. It also uses some of the abilities of the pixel display if the display supports things like partial fills, partial redraws. That is all abstracted away, so you don't have to concern yourself with that. This is still not overly friendly if, for example, I want to build a user interface, an HMI, which stands for Human Machine Interface. If I want to build something like we saw where I've got text that is updating, I don't really want to have to figure out where to draw the text, draw each character. When it changes, clear all of the characters or refresh that region and then draw a new text. It becomes a pretty onerous process anytime you want to change or move things. For static layouts, it's not horrible. So what we've done is we added another layer on top of this called MicroLayout. MicroLayout provides a user interface paradigm that is really screen and control based. So at the top level, we have the display screen here. This display screen is effectively your physical screen. On that screen, you can put two different types of things, either controls, which derive from the eye control, or a micro layout, something that derives from a layout. Now, really, a layout is also a type of control, but semantically, they are separate types of things. The layout is a group of controls. You might use those for showing a full screen and being able to hide and show that. I'll show you that, an example of that anyway, here in just a moment. The controls themselves, there are a bunch of implementations of those. And we have controls and clickable controls. Clickable if you have something like a touch screen or if you're running on Windows or Linux and you have a mouse. But you can see we've got a collection, not a huge collection, but a collection of controls that provides the ability to do general basic displays. Buttons, boxes, gradient boxes, progress bar, label, things like that. We also have a couple of more complex things for charts, line, and vertical bars. So really you can think of this as a collection, which is your screen, and then it holds a bunch of either controls or layouts, which then in turn hold controls. The layout doesn't have to be full screen. It can be partial screen, things like that. So if you're used to building things in, I don't know, WinForms or WPF, Xamarin, this will feel very, very familiar to you. So if we take a look at this as an example, we've got this bar chart here at the bottom. We've got a label here. It's actually aligned to the right, another label here aligned to the left. And if I swap, you can see I push this button and it swaps. What that's doing is it's actually taking the layout here and making that non-visible and making this layout visible. So we're just swapping the visibility of two different layouts. And then this layout right now has a circle control. It actually has, again, that icon in the center is a picture control, and it's either shown or hidden. Right now, obviously, it's hidden. So we've just got the circle control, and then we can swap this, and it changes layout for two labels and a vertical bar chart. Let's take a quick look at one last thing, and that is, as I had mentioned, the iPixel display abstracts this out, so I can take this display and move it to another display physically, even with different dimensions. But more interestingly, it allows me to prototype this on something like my desktop with a desktop pixel display. So I can do all of the development with a much faster development loop, the whole write code, hit debug, test it, edit the code, run it again. Right now, to do that, if I have to deploy to the microcontroller, it's slow. We have to do the compile, linking, trimming, push it to the device, wait for the device to boot, and then see what the effects are. It's a much slower process. So if I want to do fast iteration on building a user interface, I can just build it right on the desktop using a different type of iPixel display. And as long as I make note of the dimensions of this and potentially the color changes. So this is monocolor, my desktop is multicolor. So as long as you keep those things in mind, your code will migrate very, very easily. So let's take a look at this running on a different display right here on my desktop. First, let's take a look just real quickly at the controls that I was talking about. You can see that I have two layouts here. One for the ball, or that circle that moves around, and one for the power output, the display of the labels and the bar chart. You can see I have the ball layout. It contains this emoji, which is the icon that currently is not visible, but I've got another video that shows displaying it when a cloud command comes in. And then the circle, which is the circle that we see moving around. Those are put into this layout. Then we have a separate layout that has the label for the instantaneous current, the mean current, and then the instantaneous chart, which is a vertical bar chart. Those are all added to this layout, and then you can see the screen has two controls, which are just those two layouts, and one is visible and one is not. And then all I do to toggle it is we just change the visibility on those layouts. Now this is all abstracted out into a display service, and that service is created by my application. You can see here I have a Meadow desktop application. I also have an F7 Feather application. The F7 Feather creates a display for the physical display that we saw, whereas the desktop uses the desktop display, sets the same dimensions, 320 by 240. This is a scaling factor because I have a larger display. 320 by 240 is really small, so we're just going to triple the size of it. So if I run this, you can see it brings up the same display with the ball. Right now it's just jiggling around. It's because I don't have a physical accelerometer attached to my PC, so I used a simulated one that is just doing a random walk on simulated data. Because it's pretty interesting, I will do a separate video on this simulation stuff. So for now, just accept the fact that we have a peripheral that looks just like an accelerometer sending in simulated data here. Now I can simulate again the interrupt on that button. I've got it wired up to my tilde key on my keyboard. So if I press that, it changes the display, calling the same code, hiding and showing the layouts as appropriate. And then you can see we've got a text here and here, and then we have this lower control. The dimensions are different here because this display is actually set up larger than that small display. But you can see that I have a label up here, here, and then down below is that control. So I'm able to take my logic and move it between these different displays, and it just works. I don't have to change any code in order to make that work. In fact, I can change this display to be more like this small display by just adjusting the code. That display is 128 by 64. And you can see we've got that ball, and I change, and now the dimensions are much, much closer to what you saw on that physical display. And again, it was that easy. I just went in and I changed the display parameters and it created a different display. This allows me to go in, make changes to my code, and debug against a display much faster than if I were pushing to a physical IoT device. And there you have an example of building a simple UI for your IoT device. Until next time, remember, if you have an idea, go build it. Thanks for watching.